For the possible outcomes are one of these three. The concrete problem that we're going to solve today is to recognize the handwritten digit. For example, here this one maps to one of the output categories, which is nothing but digits 0 to 9. Similarly, here for maps to this particular output category. So we will use a training set with lot of hand digit characters, and then we'll build a model using logistic regression. And at the end of the tutorial, you will have an interesting exercise to work on. So let's jump straight into writing the code. As usual, I'm going to use my Jupyter Notebook as an IDE, and here I have imported matplotlib and also scikit-learn's dataset. So sklearn.datasets has some predefined ready-made datasets that you can use to learn machine learning. From this, I'm using load digits dataset. So if you read the documentation, all it is 1797 notebook as an IDE, and here I have imported matplotlib and also scikit-learn's dataset. So sklearn.datasets has some predefined ready-made datasets that you can use to learn machine learning. From this, I'm using handwritten digits of size 8 by 8. Okay, so it looks something like this. And what we are going to do is, given these digits, we are going to identify that what digit that is. All right, so let me just run it. So this has run fine. I am going to now call load digits method to load my training set basically, and I want to explore what this training set contains. So it contains a couple of things. It has data, which is your real data. So let's print few elements. So as it's written in the documentation, there are 1797 sample. So I'm just going to print the first one. And it's an array. Okay, as such it is an 8 by 8 image, but the image is represented as a one-dimensional array. So if you count these elements, it will be 64, which is 8 by 8. And if you want to see this particular element, then you can use matplotlib. So using load digits dataset. So if you read the documentation, all it is I'm going to do plot plt.gray, and plt has a method for the possible outcomes are one of these three. The concrete problem that we're going to solve today is to recognize the handwritten digit. For example, here this one, I'm going to do plot plt.gray, and plt has a method for the possible outcomes are one of these three. The concrete problem that we're going to maps to one of the output categories, which is nothing but digits 0 to 9. Similarly, here for maps to this particular output category. So we will use a training set with a lot of hand digit characters, and then we'll build a model using logistic regression. And at the end of the tutorial, you will have an interesting exercise to work on. So let's jump straight into writing the code. As usual, I'm going to use my Jupyter Notebook as an IDE. 97 and load digits method to load my training set basically, and data, which is your real data. So let's print few elements. So as it's written in the documentation, there are 1797 sample. So I'm just going to print the first one. It's an array. Okay, as such it is an 8 by 8 image, but the image is represented as a one-dimensional array. So if you count these elements, it will be 64, which is 8 by 8. Is your real data. So let's print few elements. So as it's written in the documentation, there are 1797 sample. So I'm just going to print the first one. It's an array, okay? As such, it is an 8 by and if you want to see this particular element, then you can use matplotlib. So I'm going to do plot plt.gray, and plt has a method called matshow, and what you can do is you can print the corresponding image. So data has the numeric data, and images will have the actual images. So you can see that data 0 and image 0, they kind of relate to each other, and the only difference between the two is that you have numeric data here versus you have an actual image. So if you want to print it like this, and you will see that see 0 1 2. Then you can just print it like this, and you will see that see 0 1 2 3 4. okay, and corresponding numbers will be in this data array. So that looks pretty straightforward. Now what we're going to do is use this to train our model. Now before we do that, let's take a look at target and target names. Okay, so our target, so if I print digits.target 0, let me print 0 to 5. So you see, like 0 to 5 is literally in the sequence. The first element is 0, 1, 2, 3. And that's what this is printing here. It is saying that this sequence, the first element is 0, 1, 2, 3. And that's what this is printing here. It is saying that this image is 0. The last image, this is 4. So this is our complete training set, which has our image as well as the target variable, like it says what it is. So we can use, before training our model, the usual thing that we do is taste split. So train this.target because that's your target variable. Okay, and if you hit Shift Tab, it will show you all the nice documentation of that API. Executing this command is I had input and output variable from my training set, and I divided them into test model. We don't the dates. Okay, so that's why we split these two. So if you look at, so I'm going to probably supply test size test size. So I want 20% of this. So this is roughly 80% of all available. Create my logistic regression model. So from this, I want to import, create a model object so that you can train it later. And you all know the way you train it is by calling a fit method. And fit method, you will call it against xtrain, sorry, y-train. Now the corresponding output it repeat will say, okay, for this image has these 4 hand written train using this xtrain and y-train dataset. So again, to repeat, xtrain has the hand written characters, and y-train will have dataset. So again, to repeat, xtrain has the hand written characters, and y-train will have the corresponding output. It will say, okay, for this image, it is 4, etc. how accurate is your model. And the way you do that value, and it will compare those y predicted value against the real value, which is y test. Turns out that my model is doing pretty good. The accuracy is 96.6. Before I call this method, what I want to do is that. So now I'm going. Now let's see. So before, and 7% almost, which is really good. So now I'm going to make my actual prediction, and you know that you have to call predict method for that. Now let's see. So before I call this method, what I want to do is I want to pick up a random sample. So let's say I'm just picking up a random sample, okay? This is actually digits.target 67. So you have to access the same index. In your target for this guy. So I will say more to predict. Now see, I'm not going to supply images here because images is all binary data. My model likes numeric data more. So I will use the same index 67, but I'm using data instead of images. Okay, this is the error you get when you're not supplying multidimensional array. So I'm just going to supply multidimensional array just for the sake of it. And you can see, let me, okay, I want to predict 96. How do I know where it didn't do well? Okay, because all the samples I tried seems to be doing pretty well. So I want to know where exactly it failed, and I want to get overall feeling of my model's accuracy. And one of the ways of doing that is confusion matrix. So I will show you what confusion matrix is really. Now for that, I have to import from this matrix. I need to import confusion matrix. Okay, and then before I do that, I need to get the predicted values. So I will say predict x test. When I run that, I get all the predicted values for this x test. Okay, and then I create a confusion matrix. And in the confusion matrix, what you supply is y test, which is the truth, and then y predicted, which is what your model predicted, and then you get confusion matrix back. When you run that, you get this 2 by 2 dimensional array, and you're wondering what the heck this is. So this is better visualized in matplotlib or seaborn, right? So I will use that library for the visualization here. I'm just going to copy paste matplotlib. It's used for visualization. Uh, this is the confusion matrix that you got. Now, the way this works is, see here you see 37 number. What it means is 37 times the truth was 0, and my model predicted it to be 0. Here this 2 means 2 times my truth was 8, meaning I fed my model the image of 8, but my model said, no, it is 1. So these are the instances where it's not doing good. So you can see that in anywhere in this area, when you don't see 0, it means your model is not working right. So here, for example, again, 2 times my images were of digit 4, but my model predicted it to be 1. So that's what this is. So confusion matrix is just a nice way of visualizing how well your model is doing. All right, now it's the time for exercise. Today's exercise is going to be using sklearn datasets iris flower dataset, which has following 4 features. So if you don't know about iris is a type of flower, and the flower has two type of leaves. One leaf is called sepal, the other one is called petal, and they have like height and width. And based on these height and widths, you can predict what kind of iris flower it is. Okay, so our data set will have 3 are these 4, which is basically petal width and height, and sepal width and height. And you will use this data set, the iris data set, and build a logistic regression model and tell me the accuracy that you can come up with. And then you can just do a few predictions using that model. All right, that's all I had for this tutorial. I have the link, and please do our input and target data set. Now, we are going to solve a classification problem using decision tree algorithm today. When you have a data set like this, it's easier to draw a decision boundary using logistic regression. But if your data set is a little complex like this, you cannot just draw a single line. You might have to split your data set again and again to come up with the decision boundaries. And this is what decision tree algorithm does for you. We will use this particular data set where you try to predict if person's salary is more than $100,000 based on the company, his job title, and the degree that he has. Now, when you look at the data set and when you give it to any human being to solve this problem, you will naturally try to build a decision tree in your brain. So first you will split the data set using the company. And here you can see what happened is if your company is Facebook, no matter what your degree or job title is, your answer is always yes. You're always getting $100,000 per annum. I mean, they have a lot of money right now and the stock is going up, revenue is going up, so they don't mind paying such a high salary. But in other two cases, you have mixed samples. So you need to ask further question. For example, for Google, I will ask what is the job position? And based on that, I have further conclusions such as if it's a business manager, the answer is always yes. Sales executive, answer is no. Computer programmer, again, I need to split my decision tree. And you can do this iteratively to come up with a tree like this. Now, this sounded very simple, but in real life, you will not have 3 attributes. You will have probably 50 attributes. And it matters in which order you split the tree. Right now, we chose company first, then job title, and then the degree. In which order you select these attributes is going to impact the performance of your algorithm. So the question arises, how do you exactly select the ordering of these features? So let's look at our example. So here we used company first. We might have used the degree instead of company, in which case our data set would be split like this. Now observe carefully. On the left-hand side, what's happening is we are getting a little bit of a pure subset. What I mean by pure subset is in the case of Facebook, all the samples are green. Okay, so this has a very low entropy. Now, if you remember the definition of entropy from your school days, it is basically the measure of randomness in your sample. Here, there is no randomness. Everything is green. So 6 green samples, 0 red, hence low entropy. Here, there is some entropy, but still majority of the samples are red. Okay, whereas on the right-hand side, for this case, 4 red, 4 green means there is total randomness. It is 50-50, hence my entropy is 1. Okay, here it's a little better, entropy is a little low. So overall, I'm thinking if I use company as shown on the left hand side, I will have a high information gain. Okay, whereas on the right hand side I have low information gain. Hence you should use an approach which gives you high information at every split. Hence we chose company as the first attribute, and in the further split also you can use high information gain criteria to divide it further. There is another term that you hear often when you're dealing with decision tree, which is Gini impurity. Now this is nothing but an impurity in your dataset. For example, when I split my sample like this at the bottom, most of the samples are red, whereas one is green. So this is almost pure, but there is a little bit of impurity, all right? It's sort of similar to entropy. I'm not going to go into mathematics too much. You can read articles on it. We'll straight away jump into writing code. I launched my Jupyter notebook and loaded the same data set into my data frame. You can see I have the same CSV file that I'm loading into my data frame. Now the first step is, once I have my data frame ready, I want to divide it in between the target variable and the independent variable. So I will call the target independent variable data frame inputs, and I will just drop, see, this is my target column, okay, target variable. So I'm just going to drop that, and I will say axis is equal to columns. Okay, so once I execute this, what's happening is my input looks like this. So it doesn't have the last column, which is my answer, and my target looks like this, which is my last column. Now, by this point, you all know that machine learning algorithms can only work on numbers. They cannot understand labels. So what we have to do is we have to convert these particular columns, these 3 columns, into numbers. And one of the ways is to use the label encoder. So from sklearn.preprocessing, I will, all right, I hit tab, so it was auto-completing, but it was slow. But see, if you hit tab, again, it's not working. This is sometimes, see, now it worked. It's funny. All right, once I import label encoder, I am going to create the object of this class, and I have 3 columns, so I have to create like 3 different objects. Okay, so first is Ali company. So is in your inputs data frame, your company column, and you can do the same thing for your job and degree column also. Data frame is going to look like it has 3 extra columns, and we have label encoded your label columns into numbers. Next step is to drop those label columns. So I'm going to create a new data frame here and just say drop all the label columns. Now all you have is numbers. So Google, it will encode it as number 2. The second thing for like train our some model, and then your model is nothing but 3, and then you can now train your model. My target variable. So I train my model. Now I'm not using test train split here just to keep things simple, but ideally you should split your data set into training set and test set, 80-20, 70-30, whatever ratio you prefer. All right, but I'm just keeping it very simple. Here it use criteria as Gini impurity by default. You get to fine, although knowing math always helps, right? Now my model is ready to predict. So the first thing I'm going to do is predict my score. All right, and the way you predict your score is you supply your input and target data set. Now pause this video for a moment and tell me what is going to be your score. The score is going to be 1 because I'm using the same data set which I use for training, and my data set was also very simple. So I was expecting that it will do very okay, it will be very accurate with my prediction, hence the score is 1. In real life, when you have a complex data set, your score will be less than 1. Okay, so now let's do some prediction. So I'm going to do predict. All right, what are we going to predict? So executive is his job and master's degree. Okay, so let's see. So that's number 2 row. Okay, so 2 2. All right, is expecting 2D array. Usually working in Google. Sales executive is his job. Master degree. Made up this data set. So that's a little disclaimer. So business manager's number. So his salary is 1. All right, so we are doing perfectly. All right, here you can have this model and you can do further prediction using the train model and by calling a predict method on that. Alrighty, now the most important part, which is the exercise. So I expect all of you to do an exercise on your own. I have a Titanic dataset. So this is showing the survival rate of passenger in a Titanic crash. This is the real dataset, and you can get this CSV file by clicking on a link in the video description below. So that link contains the Jupyter notebook that was used in this tutorial, and it has exercise subfolder. Within that you have titanic.csv. Here you should ignore all the red columns and use the remaining columns to predict the survival rate. So here the survived column is your target variable, and you have to predict the survival of a passenger based on the class, the sex, age, and the fare that he paid before onboarding Titanic ship. Okay, so that's what you have to do. Come up with the score of your model and post your score as a comment
you